All right, guys, I'm Nicolette, and today Brian and I are here to discuss the trends and design challenges in the interactive kiosk market. And joining us today, we have Matt Haga, Power Sales Engineer at Sager Electronics, Kai Lee, Product Manager over at Meanwhile, and Rich Arietta, Director of Business Development, Engineered Solutions at Sager. So you guys are going to join us today to talk all about this. Thank you so much. We appreciate everybody jumping on.
Yeah, thank you for having us.
All right. So ultimately what we want to do here today is help engineers determine their power solutions that fit their application. So first, why don't we look at the market as a whole? Obviously COVID-19 impacted the industry. It did many industries, right? But, in general, what are we looking at in terms of key varieties of kiosk applications? What types of kiosks? Maybe Matt, you could kick us off with some of this trend information.
Well, the COVID pandemic really had an effect on the way companies operate. I think they all realized that they needed to be able to continue business operations with limited human-to-human interaction. And kiosks definitely played a large part in this. Now, although that COVID really increased the kiosk usage over the last year, this trend is going to continue post-COVID. I think that all aspects of our market are really going to take part of this kiosk boom. So the global kiosk market in 2020 was around $26 billion, and this is projected to grow between 6 and 7% over the next 7 years. And this growth isn't going to be COVID related. This is going to take part in all aspects of our economy, with financial markets and security markets being showing a huge growth in this. And this could be anything from ATMs to passport checking stations at customs, or even cashing out gambling winnings at casinos. I think companies are really starting to see that kiosks are going to play a big part in their 24/7 operations, and they give them the ability to scale up and down to match their ability to handle the ebb and flow of their business.
Now, you mentioned ATMs. I mean, one of the things I saw recently, and I don't know if you guys saw this, but did you see there's now Bitcoin ATMs going out there, which is pretty crazy. Do you think that's going to also be a trend where it's like multiple currency, not just
Absolutely. I think anywhere there's the opportunity to automate anything, we're going to see kiosks proliferate in that area, particularly in the financial markets.
Yeah, and I think, Brian, you brought up a good point that with the advancement in payments and security and like the different Bitcoins and different currencies being introduced, there's definitely a surge or a new market for the different kiosks, right? And going back to the COVID topic, I think with the COVID, there are also some more creative ways for kiosks or new functions added to the kiosks. For example, like temperature sensors being added to the kiosks, or UVC disinfection for the keypads and all of that. So yeah, I think the COVID and also the overall market definitely plays a bigger role in adding more and more ways for the kiosks to be introduced. Yeah.
So I guess that leads into the adaption, how the market is going to adapt, right? I mean, more touchless, right? More self-serve, but what types of key trends, what about intelligence and complexity? What are we seeing in these types of kiosks in terms of trends in that sense?
Well, I think one of the key takeaways from 2020 is that you don't know what's coming around the corner. So having flexibility in your design is going to allow you to take advantage of all the opportunities and meet the challenges that we face. And so when it comes to kiosk design, you have to maintain flexibility. You have to be able to, one, support your core requirements. All kiosks are going to have a core set of requirements and devices like CPUs, displays, things like that designers can plan for. But when things happen like COVID-19 pandemic or local regulation changes that will allow adoption of maybe new technologies for your application, you have to be able to quickly modify your kiosk design in order to take advantage of those opportunities.
as with any technology, right? Because it sounds like you're talking about a challenge there for engineers. When it comes to designing any technology, there's always a challenge, right? So what about power challenges in this realm? What types of power challenges are engineers facing today?
Well, a key aspect of having a flexible design is the ability to scale your power to meet your specific application. So, whether or not you have to add a bill acceptor or a credit card processing equipment, or like Kai talked about, UVC LEDs for disinfecting, you need to be able to modify your power to drive these. And most likely, all of these devices are going to have different voltages, different power levels. You can't really plan for that specifically. So you have to be able to scale your power. And there's a number of ways you can do this. One of the ways I recommend is looking at a single AC to DC front end. Take, for instance, the Meanwell UHP 1000 or 500. This will give you a single AC to DC, which will help keep your leakage current down, as well as limit your EMI. And then you can use additional DC to DC converters, maybe in a distribution panel. And you can scale these by just doing a pop or no pop on your PCB to match the power requirements of your application.
Yeah, and I think Matt touched on this. Like, in addition to the different voltages, another challenge for the engineers is to meet the EMI requirements, because for the kiosks, we're fitting many different components in there and having to use multiple voltages and even multiple power supplies to power them. So meeting the EMI requirement is also a very big challenge for the engineers nowadays, especially when they're trying to add more and more features and functions into the kiosks.
You mentioned like the temperature sensors, and there's UV and UVC and things like that being added in. So how do they plan, like, okay, if I'm going to eventually add this in and scale it, like how should they plan out for things that may come down the road?
Yeah, I think so. This has to do with the designs for the kiosk manufacturers, right? They can come up with a base level design with the base features and functions like the CPUs and the screens, and then they can like Matt mentioned, they can scale the application to the end customer's needs by leaving extra slots or extra places to fit in those extra components. And one way to really support this kind of design is to utilize a modular power supply. And modular power supplies, as the name suggests, the outputs can be easily configured or customized to provide the different voltages. And some of our customers in the past, they've chosen modular power supplies with blank slots left just in there. And then they will design their base model around that. And as they need more power, more voltages, and they add more functions, they just add in more output slots into those modular power supplies. Yeah, and I think Matt can also help add on to like what he's seeing with the customers. Yeah.
Yeah, we're even seeing some instances of people creating battery powered kiosks. They're trying to get these things out as quickly as possible, maybe to the front of a store where they can't run an AC line, or they don't want an AC cord going across the store because it's a trip hazard. So in instances like this, they might have a large battery with a single voltage. In this case, they'd use DC to DC converters to break out the voltages to all their different peripherals. So any of these methods of doing this provides a scalable option that will help a customer or a kiosk designer modify their product and get to the market faster.
So then that kind of tackles this idea of not having to redesign your power every time you need to create some sort of unique solution, right?
Yeah.
Are there any
absolutely
ways that you can be flexible and scalable?
Yeah, definitely. And I think if the base design, the base model, when they're certified, when they're designed with the modular power supplies, and they also consider the optional additions or peripherals that they may be adding later on, they may certify the whole systems ahead of time, or later on they just need to do a revision, a paperwork revision, or just some additional tests. They don't need to do the whole design over and then have the whole test over again. So I think that's definitely a big time saver, and it's a really more efficient way to tackle the market.
Right. If you're not changing out that AC front end and you're only modifying your DC outputs, it's going to be much easier to go through a recertification. Maybe if you're modifying your part, and this will just help with time. It's much easier to be the first to market and gain that open floor space than to try to displace an incumbent competitor. So the faster you can get to the market, the better off you're going to be.
So Matt, you mentioned those core set of peripherals that are reused between applications. Can you just give us a rundown of what those are, just so everybody knows?
Yeah, well, typically you're going to have a computer. Almost all kiosks are going to have a software application that's going to run on that. You're going to have an LCD, backlight, some type of audio. These are just for the typical application to run on, and they also provide user feedback that's going to be necessary for any type of application. And again, this is something that can plan for, and it's going to be 90% of the design. But as events come up and changes happen in the market, you need to add to that. So being able to be flexible with your design, to add and modify it is going to benefit you in the future.
We did talk about those flexible solutions. Kai, did you want to talk about any of the Meanwhile solutions that were out there?
Yeah, sure. And I think so there we consider two paths for when tackling power solutions for kiosk designs, right? So the one path is to choose a single unit solution, a modular power, a configurable power supply that can just be configured to meet all the voltage requirements and all the power needs. And that is the easiest way, of course. But for customers, like Matt mentioned, that they may be looking for like battery powered, or they have some other considerations, like maybe they need fanless. Meanwhile, we also have a large selection of fanless AC to DC power supplies, and we also have a large selection of DC to DC modules. So they can pair AC to DC plus DC to DC to create the multiple voltage rails. And if the kiosk is battery powered, customers will also have to consider battery chargers, of course. And battery chargers, they need to be able to provide efficient and fast charging. So that's also some key considerations.
Rich, is there anything you want to talk about in terms of how Sager plays a role in all this?
If you remember, kiosks are usually designed to be sleek and really non-intrusive to their environment, right? And with user convenience in mind, not always the convenience of electronic design and layout, right? So by default, the majority of the customers that we service today in the kiosk space, are actually moving through the value-added center with some type of modification. So you can imagine that in a kiosk, let's just say it's a vertical type kiosk, the power supply is typically mounted in the base of that unit, and then we're routing cables and we're assembling harnesses that take it vertically up to the back of, let's say, the PC interface into the back of the motherboard. Some other things we've done, Kai mentioned a very unique product from Meanwhile, the UHP, which is a fanless design. So it has a base plate that you can mount that and really eliminate a fan from a design, which could be very a strong consideration for the kiosk customers. In that typically they want an enclosure to meet some type of IP rating, IP65 minimum. We're seeing a lot of IP67 and 68 right now. So that fanless design or a base plate design, convection cooled or conduction cooled, is of high interest by these kiosk manufacturers. So within Sager Power Systems, we're actually designing that base plate, because not always do they have the right footprint or space to conduct that heat. So we're actually constructing or designing different base plate designs. And some of them actually we've introduced Peltier coolers, which is an active cooling system. So you have a fan that just circulates air, can exhaust the air from the system. When you don't have that ability to exhaust it externally, you have to look at more of an active cooling system. So really, I think the majority of our customers, if not all of them, we're doing some type of active cooling. or harnessing for these power supplies to be brought up and harnessed into the back of their system.
Yeah, I also want to comment on that regarding the value add aspect and the value the distributors bring to the customers, right? And this is speaking from a past experience, one of our past customers. So for these kiosk manufacturers, they're the experts of the human interaction experience and softwares, but they may have limited experience or resources around electrical design. And Sager Power Systems, they deal with all kinds of customers and the electrical designs. So they are able to take the meanwhile power supply and then provide to the kiosk manufacturers a complete power solution that caters to their needs. And especially like we talked before about how we have this base level design and then with additions later on. So that's something that Sager Power System is able to consider for the customer and then able to help them with that, that whole generation design and then just design based around that. Yeah.
So when it comes to designing, all right. So when it comes to designing kiosks, right? Do you think there are things that design engineers are not thinking about, they're not considering when it comes to the role that power really plays in all of this?
Yeah, I think a lot of times designers will look at exactly their problem at hand, and they may be looking to save costs and design for the power requirement that they're facing right now, and not really think about any type of modifications that are necessary. And oftentimes when this happens, they might have a design that works well for a short period of time until something different happens and they have to maybe add a peripheral, add another device, and all of a sudden they don't have enough power for it. So I think that's an issue that a lot of designers face, is they don't really come up with a scalable power solution for the product.
Do you think there's going to be more sensors and more mechanicals integrated into some of these kiosks as we go forward? Like, we do that with, change in dollar bills and coins, but do you think we're going to add a lot more sensors and mechanical?
Yeah, absolutely. Going back to the UVC example, it's adding UVC LEDs to a device isn't quite as simple as you think, right? You need to add an LED driver. You need to add sensors to make sure that those UV LEDs aren't operating when a customer is using the device. So, and there's software that goes along with that. So anything like that is going to be required. Sensors to ensure the safety of a customer, to make sure that those UVCs are doing their job and not harming the customer while they're in the operation.
And with the the trends that's going on with like 24/7 operation and a humanless interaction, so that's the basis of the kiosks and why we're introducing more and more kiosks, right? I think there's a lot more data gathering going on, and then so that definitely involves more sensors around the uptime or the time that each kiosk is being used, and there's a lot of analysis being done to ensure if they need to add more kiosks or if they need to change certain functions of the kiosk, right? So really, I think it's an ongoing theme that really involves a lot more sensor and more data analysis. Yeah.
Yeah, because even if you think about that UVC example, right? One customer goes, they touch the ATM or whatever the kiosk they're touching, and then it needs a certain amount of time to run that UVC light before the next customer actually steps up to use that device.
Yep.
Yes, absolutely.
Does that play a role in the future power requirements then? Like the smarter these devices get, obviously that works with the power requirements?
Yes. Every sensor, every device that's added is probably going to add to the power, and it's probably going to be a different voltage than you accounted for. So that's why the flexibility of the NMP product or something like that, you can add DC voltages as you need them, or even tweak them. On a module to module basis will definitely help future-proof your products.
Let's go. We brought up the UVC a couple of times just now. Kai, why don't we go back there for a second? What do you think engineers can or should be using when it comes to disinfecting user interface devices?
So UVC LED is a very new technology. It's still not at the very mature stage yet, but the UVC LEDs, in comparison to the traditional UVC light sources, has the unique advantage of being a point source or being very easily customizable and shapeable in terms of the beam angle and how they want the light to shine, right? So with the introduction of the UVC LEDs, we're able to put UVC disinfection into like a very small footprint, and then just like shining on the keypads, for example, on the kiosks. And of course, that will involve unique LED drivers. And for drivers, we can introduce the AC to DC LED driver, or we also can use DC to DC LED drivers and just take power from like the modular power supply, the NMP series, for example, or like Matt mentioned, the UHP, the fanless one. So regardless what the original design uses, they can always take that and then just add a DC to DC LED driver and then power that UVC LED.
It sounds like the key message here is to plan ahead. I mean, that's what I keep hearing. plan ahead and be flexible, design flexible, right? I mean, that's just the recurring theme here as we've been talking. Is there anything else in terms of power that we should be thinking about?
Of course, planning ahead is I think the key message that we've all talked about. But also in terms of in addition to planning ahead, it's also important to consider like the footprint, the compactness of the power supplies, and something like the configurable power supply advantage is that it's very small, very compact. It's just a single AC to DC front end paired with DC to DC conversion stages. So it is definitely a lot smaller in comparison to using multiple AC to DC power supplies that give the same output, right? And in addition to that, if the kiosk is intended to be used outdoors and they need to have IP rating or a sealed design, a power supply like the UHP series being fanless and cooled by conduction, that would really bring a lot of value to shrinking the overall size of the kiosk, because now you don't need to have as big of a space internally for the air circulation and for the ventilation. Heat is extracted through the conduction cooling. So it's a lot easier to design, and so it's of course, we want to be as future-proof as possible. So I think one direction, of course, is planning ahead and leaving space for power expansion and scalability. And another aspect is to use the most high-performance power supplies on the market right now, and to get that design as advanced as possible. Because kiosks, I think, is a fast evolving industry, especially in recent years with the new features and new requirements added on. But if we can get a base level design that has scalability, then it will just solve this future proof issue.
One thing you mentioned, Kai, is like kiosks being outdoor, right, rated for weather and things like that. Do you see more people sort of dual purposing it as like things have moved outdoor with the pandemic and moved back inside, where they're just really designing for basically all weather type of kiosk?
It's definitely a trend and possibility, right? Because previously, a lot of these self-serve kiosks, they may be used indoors, and outdoors we're seeing things like ticketing kiosks for trains and all that. But with the pandemic, indoor dining is no longer an option, and for the restaurants to still enable that the operation and but they also want to support humanless interaction and ordering. So they may be considering IP-rated kiosks and move them outdoors, and that's also another possibility for battery-powered. So for battery-powered, they're more mobile and they need to have more flexibility. So they need to consider these different environments and different possibilities. So they may need that IP rating and be moved outside. So that's something that traditionally you wouldn't consider for something that's used inside restaurants, right?
Mm-hmm. How does that change the power, though? That's my question. How does that change your power requirements?
Yeah, so I think Matt, we briefly discussed before. So in terms of power, when we move from AC-powered kiosk device to a battery-powered, battery will provide DC power instead. So now we need to use the DC to DC converters to provide that. Yeah.
Got it.
Well, in addition to that, Nicolette, we have customers that, if it's a battery operated system at night or at certain staged intervals, these kiosks have to move back into a central location for charging.
Right.
And we could address that charging system with a power supply.
Yeah, so usually not just a charger or like adapter. For something that's big with a big battery inside, they may require a specific charging dock.
Right.
So it's a whole different design, a whole new system introduced, right? So
especially when you're moving kiosk, right? You know?
Right.
yeah.
Do you think are there solar powered kiosks in places? I've never seen them. I was just wondering. I was curious.
I think that's
I haven't
go ahead. Yeah.
I haven't seen them. You might have a solar charger to help charge a battery-powered kiosk, but I don't know that it would provide enough power to really drive a kiosk. The computer and the display, typically you want some pretty bright lights and things like that, and those power requirements might be above what solar is going to give you right now.
So Kai, why don't you leave us with some of the suitable products that engineers should be thinking about right now that Meanwell's got?
Yeah, so we keep talking about the configurable, right? So meanwhile, we have our new generation platform, the NMP modular power supplies, which supports up to six slots in a single 1U height 1,200 watt package. That's a very compact, high power density package. And recently, in 2020, we added more output modules. We added the dual output, the NMD 240 dual output module, to make the configurations more flexible and to support more output voltages. And that goes along very nicely with the recent design challenges that we see in the kiosk space of adding more and more features like temperature sensors or UVC LEDs that were never considered before. So that's the configurable power supply aspect. And we also kept talking about like the single output AC to DC solutions, and that is the UHP product family. And the product family, it offers from 200 watts all the way to 2,500 watts. So customers, the kiosk designers, they can use multiple of the lower wattage units, or they can opt to use a single high wattage unit as a front end, and then they pair with more DC to DC output modules. The DC to DC output modules and DC DC converters, meanwhile, also have a large selection, so ranging from all the different wattages. And yeah, so I think those are the two ways that I mentioned earlier, the two ways customers can go with designing the power supplies. And meanwhile, we currently think those are the most suitable to go inside of these kiosk designs.
All right, so we've learned a little bit about the products that Meanwell's got going on, and Sager, Rich, what do you have to add there? How do you then play a role and tie this all up for us?
Sure, right. So again, we mentioned that a lot of our customers are using these power supplies and trying to route the power to the back of those motherboards, let's say. So we're harnessing a lot of these power supplies for our customers. And then the other product that Kai mentioned, the UHP, with it needing a base plate to get the cooling out of that system, we've done multiple modifications and custom designs, just standalone aluminum plates, all the way up to active cooling designs using Peltier coolers.
All right, guys. So what I'd love to do for everybody listening is really tie this up for the engineers and give us the key takeaways that we should walk away from this discussion with. I mean, we've listened, we've learned about future proofing, right? That's pretty important. What would you like to leave us with today? Matt, why don't you round us out?
Yeah, I think the key takeaway is to stay flexible. I mean, we've seen throughout this pandemic established businesses go under because they were not able to adapt quickly enough to the changing landscape. But the companies that were more flexible and able to implement new technologies to face these challenges were able to continue their operations and even prosper. So stay flexible and think ahead with your design.
And for more information, you can head over to Sager. We'll put the link in the description. We'll also have it here on the screen for you. We've got some resources there for you as well. So you can feel free to head over there and learn more. Thank you, guys. We really appreciate your time today. And thank you for educating us on this very important topic.
Thank you.
Thank you.
Yeah, no sweat. Good to see you guys.
You too.
Take care.